Welcome back to another linear equations video. This one's finding the full equation of a straight line on a graph. Let's take a look. Now in the last video we learned how to calculate the slope or the rate of change of a straight line. And the only other characteristic that we need to be able to define a straight line is something called the initial value. And we're going to call it the y-intercept. And the term y-intercept is a bit of a giveaway here. What we're talking about is the point where a straight line crosses over that y-axis. And if we know the slope and the y-intercept, then we've got all the information we need to be able to tell any line apart from any other that could possibly exist. So when we talk about the equation of a straight line, we're talking about a way to define a line and differentiate it from any other line on the Cartesian plane. So an equation is going to use a combination of the slope and the y-intercept to describe exactly what a straight line looks like. Now when I say we're defining or describing a line, it's the exact same thing as if we were asked to define or describe the word desk. You would probably say it's got 4 legs, a flat horizontal surface to work on. You would describe it for me. Well, we can do the same thing about a straight line. You could tell me how steep the line is and whether it's increasing or decreasing on the graph. And then you'd be able to tell me how high up or how low down the line crosses the y-axis. And once you've done that, you've defined or described the line perfectly. So the format for writing the equation of a line looks exactly like this. And we read that y equals ax plus b. And you know from the last video that a represents the slope, and I'm telling you right now that b represents the y-intercept. So if a represents the slope and b represents the y-intercept, what are the x and the y doing in that equation? Well, x and y are just holding the place of coordinates of any point that might lie on the line that we're talking about. And actually that comes in pretty handy because if x and y represent the coordinates of any point along the line, then we could plug in a set of coordinates to an equation and see if a point lies on a line or not. You're going to see that in the example at the end of the video. But what you need to know for now is that the a in the equation gets replaced with the slope of our line, the letter b in the equation gets replaced with our y-intercept, and the x and the y, those stay as variables. They stay x and y. So how do we use the equation of a line in a question? Well, here goes one pretty common example. If I were to tell you that a line passes through the points 7 and negative 8 on the Cartesian plane, you could probably picture that pretty well. Now, if I also told you that the same line has a slope of negative 2, you know that you're talking about a line that passes through that set of coordinates with a descending slope on the graph. But if I asked you exactly what is the y-intercept of that line, or if I asked you what's the equation of that line, you'd be able to find that pretty easily. And here's how it goes. The first thing to do is always to write out the format of the equation, and you know that's y equals ax plus b. Now I just told you the slope was negative 2, so you're going to go ahead and plug that in where you see a, and I told you that x and y were 7 and negative 8. So where you see x, you replace it with 7. Where you see y, you replace it with negative 8. And since we don't know the y-intercept, that's b, we're going to leave the b as a variable. And to solve for the y-intercept, all I need to do is carry out my operations and isolate that variable. And now that I've solved for b and I can see its value is 6, I can write out the equation of that line and define it perfectly. And it's going to be y equals negative 2x plus 6. Negative 2 is the slope and positive 6 is the y-intercept. And now that I have the equation of the line, I could plug in 7 and negative 8 and just confirm that I did my work properly, and that 7 and negative 8, when plugged in for x and y, keep the equation perfectly balanced. Now, as you can see, that worked out well. So I'm going to plug in another point that lies on that line and show you that you could plug in any set of coordinates along the line and you'd get a balanced equation after you do the math. Now that also works to prove that a point does not lie on the line that I just defined. So for example, if I plug in this set of coordinates, you're going to see that it's not on the line visually, and you're going to see that the math doesn't work out. My equation does not stay balanced, proving that the point's not on the line. Now let's watch a couple of examples on questions they could ask about the equation of a straight line.